Another question from NEET examination, a little complicated and lengthy. You do not expect this to do this in 1 minute or less than 1 minute, you will definitely take more than that, unless you are familiar with the concept and you are so fast in your calculation. There are two identical glass lenses, refractive index 3/2, equiconvex lenses of focal length f each. So, these are identical in every aspect and they are kept in contact, and the space between the two lenses is filled with water. Refractive index 4/3, what is the focal length of the combination? This is from thin lenses in contact. And how many lenses are here? How many lenses are here? There are two glass lenses and one water lens in between. So, I can draw the diagram like this. There is one lens and there is a similar one here. Okay, there are two lenses. Their focal length are equal. So, this is focal length f, this is focal length f, but in the space between them is filled with the water. So, this is filled with water. See, basic concept of this one is in a question which we discussed in the last sessions. In NCERT there is one question with a lens of water. Okay. So, this is the combination. So, here you have three lenses. Therefore, the combination have as a focal length 1/f1 plus 1/f2 plus 1/f3. But out of this f1, if I call it as this is the first one, this is the second one, this is the third one, then I will say both f1 is equal to f2 and that is given as f. You need to find out what is f2 to get the answer. You should find f2. Okay, let us proceed. First of all, from the given data of focal length and the refractive index, I am going to find out one unknown quantity, that is radius of curvature. It's equiconvex lens, so radius on both the sides will be the same. You should know that to find the focal length of the concave lens, you need the radius of curvature, and that radius of curvature is equal to that of the convex lens. Let us apply the equation of double convex lens focal length shortcut equation, r by 2 times n minus 1. So, f is given to you, r is not given to you, 2 times refractive index of glass given 3/2. 3/2 means it is 1.5 minus 1. So, this is equal to r by 2, this is equal to r. So, radius of curvature is equal to focal length. This is the focal length of the convex lens alone, because I will tell you, you calculate convex. This is a system of three lenses, 1, 2 and 3, and we assume that this is made of glass, it is in air, this is made of water but that is in air, this is glass but that is in air. So, this is for a glass lens in air. So, this is the equation, I get r is equal to f. The same r is applicable for concave lens also. Okay. Now, this is it. Okay. Now, what is the focal length of the concave lens? For the concave lens, equation is minus r divided by 2 into n minus 1. Focal length f2. This is equal to minus, we know r is equal to f, we proved from the previous section. So, I can substitute that here, f divided by 2 into what is the refractive index of water. See, I am talking about water lens in air. So, f, this is 4/3, it is given 4/3, 4 divided by 3 minus 1. So, this gives you minus f divided by 2 into 4/3 minus 1 is 1/3. So, this gives you focal length of minus 3/2 f. This is the focal length of the concave lens f2. f1, f3 are equal, but f2 is minus 3/2 f. Fine. Now, let us calculate the total focal length. The total focal length is now given by the equation 1/f equal to 1/f1 plus 1/f2 plus 1/f3, which is equal to 1 by focal length of the first convex lens is taken as f plus focal length of the concave lens must be taken the minus value that we proved here. It is equal to 3/2 f with minus sign plus 1/f focal length of the convex lens again is f. So, this will give you 1 by f and 1 by f will give you 2 by f plus, this will become minus, this 3 by 2, f will become reciprocal of that one, will give you minus 2 by 3 f. Okay. So, this you can calculate, this gives you 1 by f common bracket 2 minus 2 by 3, and this is nothing but this is equal to 1 by f into 6 minus 2 divided by 3, and this will give you 4 by 3f, 4 by 3f. You want focal length of the combination, that should be the reciprocal of this one. So, this will become 3f by 4. So, that will be your answer. The focal length is 3f by 4. This topic is actually not there in NCERT, but there is one exercise where they asked this question, something related to this question, but this came in NEET 2017. We studied about dispersion in a prism, and during that dispersion we said that there is a deviation, angle of deviation, and we studied that for small angle prism, angle of deviation is given by a simple equation, angle of deviation is given by n minus 1 into a, where a is the angle of the prism. We know this thing. Now, what is asked here, a thin prism having refracting angle 10 degree is made of glass of 1.42. This prism is combined with another thin prism of glass of refractive index 1.7. This combination produces dispersion without deviation. What is the angle of the second prism? Understand that when you have one prism like this, and if you pass white light, violet colors will split, you will get a spectrum. Then if you place another prism inverted here with a proper refractive index, then these light rays will join, they can go like this and get a dispersion, till you get a wider dispersion. So, here light rays are undergoing both the dispersion as well as deviation. In this case, what you want dispersion but without a deviation, and this is impossible. You can't have dispersion without deviation, because dispersion itself is due to different deviation of light. So, what is the meaning of dispersion without deviation? When they say without deviation, what they mean is that the mean wavelength will not have a deviation. Mean wavelength, we know violet to red color, yellow is taken as the mean wavelength. So, yellow color may not undergo much deviation, that is the meaning of this. So, when we say dispersion without deviation, the mean wavelength will not have a deviation. One more point, this refractive index for violet color is greater than refractive index of red color. So, different colors will have different refractive index. So, whenever we say refractive index of glass is 1.5 etc., what are we aiming at? We are actually meaning that this is the refractive index of the mean color or the yellow color. For the yellow color, this is the refractive index. So, this is the idea behind the dispersion without a deviation. I will show you a better diagram than this. There are two types of glasses known as the crown glass and the flint glass. Okay. So, we can use a crown glass and a flint glass like this, and you can see that here the white light coming, the color which is coming, white light, this white color light gets it disperses red color and violet color, and inside the flint prism they combine to go like this. So, roughly speaking, the mean color yellow color will follow a path like this. From here this will follow like this, and of course the deviation is not very great. So, we can say there is no much deviation. So, what is the condition for this? Condition is that this prism will deviate light, this will also deviate light. If one deviates to the right side, the second one deviates to the left side, then you can cancel the deviation. So, deviation by first one plus deviation by the second one must be equal to 0. So, if I say deviation from the first prism plus deviation from the second prism will give you 0, then there is no much deviation. This is for the mean color. Or the magnitude of deviation in the first one and the magnitude of the deviation in the second one must be the same. Since this is a very small, the diagram is not correct because these are shown as large angle, but it should be very small angle. If it is very small angle, for the first prism I can write n1 minus 1 into a1, and for the second prism I can write n2 minus 1 into a2. That is it here, n1 minus 1 a1 equal to n2 minus 1 a2. This is the condition for dispersion without deviation. So the calculation is simple now. You have equation, direct equation. What to write? n1 minus 1 into a1 should be equal to n2 minus 1 into a2. What are given? n1 is given 1.42 minus 1 into a1 is given as 10 degree equal to 1.7 minus 1 into a2. We need to calculate a2. So what is this? This is 4.2 equal to 0.782. So what is a2? a2 equal to 6 degree. You have option 6 degree. The first option is your right answer. Concave mirror for phase viewing. For shaving purposes we use concave mirror. When we place them closer you can see phase larger. Focal length is given. The distance at which you hold the mirror from your face in order to see your image upright, it should be upright with a magnification of 5. See, when we studied magnification, we studied that magnification is positive for erect images, and magnification is greater than, the magnitude of the magnification is greater than 1 for enlarged images. So here upright, erect means positive magnification and of 5 magnitude, it should be enlarged. So here what should I take? I should take m as plus 5. Magnification is plus 5 and focal length of the concave mirror is given as 0.4, and we know for a concave mirror focal length is taken negative in the sign convention. We need to find out the distance at which the face and the distance between face and mirror, that is nothing but the object distance. Definitely you can go for the 1 by v plus 1 by u 1 by f equation, but I am going to do something different here. Okay, watch out. What is the equation for image distance in a mirror? Image distance in a mirror is given by uf by u minus f from your mirror equation. What is magnification in a mirror? It is minus v by u. So this is nothing but, see, the first equation implies v by u is nothing but minus bracket. What is v by u from the first equation? It is f divided by u minus f. F divided by u minus f. Therefore, magnification for a mirror is given by the equation f divided by f minus u. This is the equation for magnification of a mirror. Substitute the value and find out u. What is the magnification m given? M is given as plus 5 equal to, what is f given? F is given as minus 0.4 divided by, what is f again? Minus 0.4 minus u. Let us solve it. 5 into minus 0.4 minus 2 minus 5u equal to minus 0.4. You need to find u, so we will keep those terms to this side. So minus 2 plus 0.4 is equal to 5u. So u equal to, this is minus 1.6 divided by 5. Minus 1.6 divided by 5 will give you 0.32 minus meter. So the face and the mirror must be separated by a distance of 32 centimeter, approximately this much, to see that large. So your answer must be 0.32 meter. Negative sign, of course u must be negative. This is not a very in-depth question, but this relates to one question asked in 2019 JEE. So JEE people, watch out. Light travels through a glass plate of thickness T. So, we have a glass slab whose thickness is given as T and refractive index given as mu. C is the velocity of light in vacuum, the time taken by light to travel, light to travel this thickness of glass is. It is very simple. Here the problem is that I cannot take time as T because it is given as thickness. So, there is a glass slab, okay, whose thickness is given as T and light is going through the glass slab. In air its speed is c. This material has got a refractive index mu. So, when it enters glass its speed will decrease, speed will become v. Now, the time taken to travel that distance I will take as capital T. This should be equal to the thickness which is the distance travelled by the speed v. And this is nothing but the thickness by what is speed in a medium, that we know by the definition of refractive index, that is c divided by mu. So, your answer is mu into T divided by c. This is the time taken by light to travel. This is the answer to your question, mu T by c. But my point is not that one. When a light ray passes through this much of medium, it takes this much of time. What would be the distance that the light can travel in vacuum in the same time? The distance that light could have travelled in vacuum in this time is, let us take it as, yes, the distance to be travelled, that is always speed into time. Speed of light in vacuum must be c into the time here is mu T divided by c. So, you will get it as mu T. So, there is a thickness T in medium. Light travel a particular thickness T in a medium. At the same time, light could have travelled mu into T in vacuum. This distance, this equivalent distance is called optical path of light. It is called optical path length. Optical path is the distance light can travel in vacuum during the time it travels in another medium, and that is always distance in the medium into refractive index of the medium. See, distance in the medium is this thickness, in vacuum it is mu times the thickness. This concept came 2019 JEE. That is why I brought this question. Read about optical path length. It is the equivalent distance travel in vacuum by the time the light travels in a given medium. It is always given by refractive index into distance in vacuum. Refractive index into distance in the medium, refractive index into distance in the medium. We will apply this in another question. This is a question from 2019 JEE. A ray of light AO, so you can see AO, ray of light is coming AO, incident on glass, it is coming in vacuum. So, this is vacuum, this is glass, and the incident angle is given here as 60 degree, and the refracted angle that is also given, that is given as 30 degree. The optical path length of light ray from A to B, optical path length, I just said optical path length, this is vacuum. In vacuum there is no optical path, the path in vacuum is optical path. So, in vacuum the path length is AO, you can calculate it from the geometry. But in the medium the path length is OB, but that should be multiplied by the refractive index of glass to get the actual path length. Okay. So, the final answer would be like this, the optical path length is equal to AO because it is in vacuum plus the refractive index of the glass with respect to vacuum Ng into the path length OB. This is your answer. Fine. Now you can calculate what is Ng. How do we calculate Ng? You can apply Snell's rule, then you can find out N glass is equal to sine 60 by sine 30. So, that will give you root 3. This is the refractive index of glass with respect to vacuum. Okay. That is it. Now, what is AO that you can calculate? It is given, this distance is given as A. This angle is 60 degree. So, this angle is also equal to 60 degree. So we can calculate AO from that triangle. You can calculate AO is equal to AO. You can see A by AO equal to cos 60. So AO should be equal to 2A. Now in this triangle here, you can calculate OB. This is given as B. This side is B. That side is B. So you'll get the second diagram. You'll get OB equal to. We can see OB. This angle is 30 degree. This angle is 30 degree. So this is the side B. This side is B. You need to find out this thing, and that must be like 2 by root 3B. Now substitute in this equation optical path. I will do here. Optical path is equal to AO equal to 2A plus refractive index is root 3 into 2B by root 3. Root 3 cancel, you will get it as 2A plus 2B as your answer. Option 2A plus 2B, option D is your answer. Just use the geometry. Again another question with a telescope, simple telescope. Do not worry about simple telescope because the telescope that we study has got only 2 lenses. That is why it is a simple one. The modern telescopes has got multi lenses, so that is why this is called simple telescope, consisting of objective of focal length 60 and a single eye lens of focal length 5 cm is focused on a distant object in such a way that parallel light rays emerge from the eye lens. What does that mean? This is an indicator. You know about indicators in questions? There will be certain word sentences which will give you how to think, what to think. Parallel light rays emerge from the eye lens means, see, in a telescope, objective, eye lens. Okay. Parallel light rays emerge means from the eye lens, light rays come parallel to the eye. When they come parallel, the final image is at infinity. This is the idea. Parallel light rays emerging from the eye lens means final image is at infinity. If the object subtends an angle of 2 degree at the objective, the angular width of the image. Simple idea. They are saying object subtends an angle 2 degree means angular size of the object is equal to 2 degree. What is the angular size of the image? Theta I is how much? Simple. We know theta I by theta O is what we call as angular magnification, and when the final image is at infinity, angular magnification of a telescope is given by FO by FE. Therefore, theta of the image is nothing but FO by FE into theta of the object. Pretty straightforward. FO is given as 60, FE is given as 5. So, this gives you magnification of 12 into angular size 2 will give you 24 degree angular size. Option B. So, the telescope, a small angle of 2 degree is seen as a large angle 24 degree. That is why we can see more detail of the object. That is how a telescope works. Two thin convex lenses, focal length 20 and 5 are placed at a distance d. A parallel beam incident on the first lens emerges as a parallel beam from the second lens. Then value of d is how much? So, by drawing the ray diagram, you can directly get the answer. There is one convex lens, there is another convex lens. Say they are fitted coaxially. A parallel beam emerges like this. It comes out as a parallel beam. Fine. A parallel beam entering a lens will focus at its focal length, which is 20 centimeter somewhere here, and parallel ray will emerge only when the light rays are coming from the focus. So, this should be focusing like this. So, this distance should be equal to focal length of the first lens 20 and this must be equal to 5. So, the total distance d is equal to 25 centimeter. You can verify this mathematically by putting u equal to infinity for the first lens and v equal to infinity for the second lens. You can verify this. I say no, this is okay. So, my dear students, we have completed most of the areas in ray optics, everything in NCERT, and most of the things related to your entrance. But of course, there are a lot of other topics to be covered in an extensive study. This is only a basic level of understanding of the topic. You do more number of questions, it will be easy, it is not very difficult, because ray optics is such an area where the theory seems to be pretty easy, but numericals are not. Only after doing so many number of numericals, your ideas will be strong and concrete. Wish you all the best.